Hello all, welcome to the course EV, Vehicle Dynamics and Electric Motor Drives. We have seen the part 1 of this course where discussions on vehicle dynamics has taken place. And now we are going to deal with the next most important part of electric vehicle, which is basically motor drives. So this is Avnish from IIT Delhi. Basically, I am assistant professor at Department of Energy Science and Engineering, and I've been dealing with the aspects of power electronics related to electric vehicle and several other applications. If we see at the basic components of electric vehicle, a typical layout is shown over here. We find that the electric vehicle contains a charger and electric motor, which is basically connected to the wheel through the shaft. And then there is a DC to AC power converter, which is basically installed for operating the electric motor as per requirement. So together it forms the motor drive unit for the electric vehicle. We may have some other DC-DC converters which are required for auxiliary units and a DC-DC converter for charging and discharging the battery pack as per the requirement. The charging options for the electric vehicle, as we have seen in the previous part, are basically level 1 AC charging or level 2 AC charging, or there could be level 3 DC fast chargers. So with this, we are now ready to have a discussion on electric motor drives. Now, different types of electric vehicle may have various types of electric motor drives installed with that. So a typical overview of how different types of motor drives and its power level is spread over for different types of electric vehicle is shown over here. So we have taken example of almost 20 electric vehicles, including some 2 or 3 wheelers and then some low end cars, some high end 4-wheeler cars, and going all the way up to a pickup truck. So what we find that primarily for the 2-wheelers and 3-wheelers, the power level is confined up to 50 kilowatt and torque is confined up to 200 Newton meter. If we talk about the 4-wheelers, which are in the moderate power level range, the power is basically confined up to 200 kilowatt and torque level goes up to 400 Newton meter. We have some high-end cars where the power may go up to 600 kilowatt while the torque is restricted up to 400 Newton meter. We have the high-end SUVs which basically require or demand more torque, which is going all the way up to 800 Newton meter while the power is confined up to 400 kilowatt. The option 20 or the number 20 pickup truck is basically having power up to 450 kilowatt and torque going up to 900 Newton meter. In this graph, we also see circles with different colors, which basically signifies the different types of motors which are involved with the electric vehicle. So we have blue colors, blue circles, which are basically indicating the BLDC motor drives. There are some magenta color circles which are basically indicating the switch reluctance motor drives, and then there are green circles which are primarily dominating the graph are basically the permanent magnet synchronous motor. Then we have induction motors which are basically appearing for higher power levels electric vehicle drives, and these are basically indicating the induction motor drives. So what we find that the electric vehicle technology primarily uses these 4 types of motors which are involved over here. So going ahead in this course, we are going to discuss about these motor drives, which are basically SRM, BLDC, PMSM, IM. And to proceed with these motor drives, we do need to have some basic understanding about the fundamentals of electromagnetic torque, the control principle, and other aspects of motor drive, which is why we are going to have the separately excited DC motor as an example to have better understanding of our control and machine aspects. So we would discuss the basic principles involving the operation of these machines and the generation of electromagnetic torque. Going ahead, we would discuss the requirements of power electronic converters for different machines. It could be DC-DC converter, DC to AC converter, or any other special type of converter. We would also have discussion on the pulse width modulation techniques, primarily required for the multi-phase AC machines, PMSM and induction motors. After this, we would take a closer look on the modeling of these machines in a reference frame or in a domain where the control principles can be developed conveniently. Further, we would discuss the dynamics and control of these motor drives. At the end of this course, we would also have a case study involving some high-end SUV or pickup truck to understand the criticalities involved with the design and control of these vehicles. So the course would revolve around these topics, and we would be having adequate amount of simulation study and examples to understand whatever principles we would be discussing in this course. So let us proceed with part 2 of this course, and let us try to develop the concepts from the basic principles to the advanced control techniques which are presently being used in the electric vehicle industry. Thank you.